thank you so very much for joining us here on our channel. I'm still Hamza Luwama, and I'm here today to take you through what we are going to call implicit functions. And these implicit functions are functions which we are going to differentiate using the technique of differentiating implicit functions. In this sense, we shall expect the following. For example, if I may have a function of the kind x squared plus 2xy plus 3y cubed minus 6y plus 4 is equal to 0, and they can ask you to find dy of dx of such a function. So in actual sense, they're asking you to differentiate this function, which is an implicit function. An implicit function is one which has got terms of x and y mixed together. And these terms of x and y, when they're mixed together, we have to differentiate them using what we call the product rule if they are merged. If they are not merged, every time we differentiate y, we attach y with the differential what? Coefficient. And the differential coefficient is always dy of dx. So to begin with, I will differentiate x, for example, 2x with respect to x, plus differentiate 2. If I differentiate x, I will get y when I've differentiated x with respect to x, plus now keep x a constant, differentiate y, I will have differentiated y with respect to y, plus when you differentiate this y, you will have 9y squared with respect to y, minus 6 with respect to y, plus 0 is equal to 0. When I differentiate a 4, I get a 0. The other side had a 0 already. Now, after doing so, we can now divide everything by dx. If I divide everything by dx, this is what will happen. 2x d of x out of x plus 2y d of x with respect to x plus x dy of dx plus 9y squared of dy of dx minus 6 dy of dx is equal to 0. Now I have differentiated with respect to x and with respect to y, but I've divided every term by dx, sorry. Now, these differential coefficients, dx is always a 1. Or it behaves like as if you are dividing dx with dx, which gives you 1. So this will give you 1. This also will give you 1. Then this one will exist as a differential coefficient. Likewise, this one also will exist as a differential coefficient. Likewise, that also will exist as a differential coefficient. Now, when they exist as a differential coefficient, you are looking for dy dx. So carry out factorization. You'll get 2x plus 2y plus x plus 9y squared minus 6 dy of dx. In actual sense, whenever you have the differential coefficient dy dx, you have to know that that means at that point we must have differentiated with respect to y, or we must have differentiated y. So whenever you differentiate y, we shall attach a differential coefficient. We differentiated 6y, we got 6 with dy dx. We differentiated 3y squared, we got 9y squared, 3y cubed, we got 9y squared. We have attached a differential coefficient dy dx. So therefore, the whole of this is also equal to what? 0. If that is equal to 0, make dy dx the subject. When I take it over the other side, I'll have 6 minus x minus 9y squared. If they told us maybe at a point 1, negative 1, then we are going to investigate exactly what that value is. It's going to be equal to 2x plus 2y. So in general, dy dx will be 2x plus 2y divided by 6 minus x minus 9y squared. If that is our solution, if they told you at a given point, then this point has to be substituted. So at that point, it means dy dx will be, when x is 1 and y is -1, I'll have 2x will be 2 minus 2 for y divided by 6 minus 1 minus 9, and the answer will be 0. So it means the derivative of this simplest function at the point y is -1, x is 1. When I substitute them, I'll get the derivative as being equal to 0. So implicit functions, that's how they behave, and that's how they look like. It can be set in a sense that they ask you to just differentiate. They can ask you for the tangent, they can ask you for the point, or for the equation of the tangent. They can ask you to get the gradient at that point. In that sense, you do carry out the differentiation using implicit functions technique. Then also go ahead and make sure that all the time we differentiate y, we attach a differential coefficient. And with that, you would have learned how to differentiate derivatives of implicit functions. Once again, I would like to thank you so much for always tuning into our channels. Thank you for liking our videos and sharing them, and thank you for subscribing. Those who have not yet hit the subscribe button, please do so, as you'll be doing a very good job in promoting this channel and promoting our videos. Have a blessed day. See you next time.